Now we will talk about another 3D surface finishing processes. Um, Over here we have 13 of them. We saw earlier the using of contour finish as well as our flow line. Now we will take a look at the top surface of this protrusion. As it is something circular in nature, it should be better handled with this spiral or the radial. These two will be more appropriate for circular cross section. Go with radial. So first is the surface that we are going to machine. Select the surface which is only the top over here, and selection. We need to cut it to size with 0 allowance left over. And our cutter. So this time we may want to make use of a ball and mill, which will be more suitable. Create tool and we select ball and mill. Okay, we make use of a smaller tool, 6 mm diameter. Next, over here we are having a high speed steel. We like to make use of coolant as seen before. So this cutter is having 4 cutting edges. We do the computation of the speed and feed rate. Finish. This is now our cutter number 3 having these operating conditions. Go to the cut parameters. Now this is what we mean by the radial direction. Starting from, for example, the center, it travel in this radial way. Step over and scale up. This is to control how good is the surface finish. Now assuming that we like to have surface finish scale up height 0.01, this will translate as a step over distance of 0.48. So this will space out how many cuts are required. Center point is where the radial point is. From that it goes out in the radial direction. So I need to select the center point. Center point. Now over here we do not have any specific center point. Doesn't matter. If I go to the top view, over here, I can select zoom in. Roughly I say this is my starting point. So you do not really need to get it to the exact point. But somewhere here it will go radial direction, it will cover up the whole surface. Inner radius is talking about from the center we selected, we cut from the center out. Outer radius is where you like to end. Presently it is having 12 mm. But of course I don't know whether 12 mm is enough for me. Now let us try this way. I say I uncheck this. Let the system decide how much it should go. Linking parameters. This predict how the cutter is going to approach. Right. We will accept all of this and see how it works. Confirm. Okay, now if I select the two paths, it covers up the whole area, and also the cutter actually go a little bit beyond with a radius approach over here. See what is the final outcome. I go and select everything, verify. Okay, I may like to see just the end result. Now, if we zoom in, this surface, this surface, we haven't cut yet. That is the radial direction cutting surface. And you notice that as the cutter go along here, it also cut a little bit on this sloping wall. So this may not be desirable. As you can see over here, we may cause overcutting in this region. Now, what we can do over here is, I may not want the cutter to cut on this face. This cutter, I like to just focus on this upper surface. We can make use of the avoidance. So avoidance, I activate this, I say this surface, I want to avoid. I don't want the cutter to touch here. And selection. Now here I can indicate how much extent I like to impose on this wall so that the cutter is not really touching the wall. For example, on this wall stop, I can say I don't want you to touch it. You can go just as close as 0.3 from it. So in other words, I will definitely be having some material left behind for that of the finishing on this side wall. Okay, confirm. Let us see how it works. We do a regeneration. If we take a look at the cutter now, you notice that it doesn't cover the bottom part over here. We do a verify of all of the processes, all processes, and result. Okay, so now if we magnify, we can see that it never touched the wall over here. And one thing to take a look is, if I'm going to do the verify, every time I will have to start from the beginning, which is very time consuming. So over here, what I can do is, I could create a stock. I could create a stock at this juncture, and then using this stock, I will make use of it to verify the final cutting on this surface, as well as the root corner radius here. That will make life easier. We close this, and then after operation 4, we can say stock model. Ask it to generate a stock model. So this is what we have after radial finishing. So how to compute this? Using the stock setup. This was the stock setup. And source operation. We select all the operations. So it will do a subtraction. After these operations, what is the final result look like? Okay, I confirm. It will compute the stock model. model. It will take a short while to get this being computed, and after the computation you should do a file saving. We should do the file saving, file save as. Okay, I will call this radial, radial direction. Save. Now this is the model. After the operation 4, I have this situation. Something that I need to address over here, there as well, and this is a radial direction. We shall look into another finishing operation in a short while.